Okay, good day to Dr. JC. My name is SITI BINTI Hamid. Today I'll be presenting about the experiment set 4 about varying training sample set. So the goal for this experiment is to examine if adding more training data will lead to a better performance. We're going to use the best models that have been chosen from the first set of experiment, which is SVR. From experiment set 2 is SVR with feature selections. For set 3 is linear regression. So we're going to train this model using a 10% of training data and gradually add another 10% more until it reaches 100%. And the performance metric we'll be using is mean squared error, mean absolute error, and R squared. So this is the model performance versus training data percentage using MSE. So from this visualization, we can see that as the percentage of training data increase, the mean squared error will decrease. So this actually represents that the higher percentage of training data, it makes the model performance better. And from here, we can see that SVR for set 1 and set 2 is actually giving exactly the same performance. So that's why they overlay with each other over here. The blue and the green means that SVR set 1 and set 2 overlay. So from this analysis, we can see that linear regression with the green dotted, with the green line, is actually perform better than SVR set 1 and set 2. And we can see also that the convergence happens when the training data set starts from like maybe 70 until 100%. So this means like if adding more training data at this point might give like no better performance compared to what we already have. So for the second one is model performance using R squared. So from here, we can see that when the percentage of training data increased, the R squared also increased. It also still reflects that the higher percentage of training data make the model performance better. And then the SVR set 1 and set 2 still overlay with each other because they reflect exactly the same performance metric. And then we can see that linear regression over here still better, performs slightly better than SVR set 1 and set 2. So again, for R squared, the best one is linear regression. As for the third one, model performance versus training data percentage using mean absolute error. So from here, we can see when the percentage of training data increase, the mean absolute error decrease. And we can see that from here, it's actually SVR set 1 and set 2 performs better than linear regressions. Here, over here. And then we can see the convergence happens like maybe between 70% to 100% of training data. So, and then it still reflects that the higher percentage of training data makes the performance better. So, as a conclusion, based on the analysis that we have did just now, we can say that the best model for this experiment is actually linear regression because it outperforms SVR set 1 and set 2 on two performance metric, which is R squared and MSE. And that's all from me. Thank you.